Welcome back. In this lesson, we are going to learn a very important topic, which is object-oriented programming, which is different from what we learn throughout the courses, okay? So let's get started. What is the difference between functional and object-oriented programming? Throughout the last lessons, we have been talking about functional programming, and we talked about functions and how we can have loops in functions and so on. Now we are talking about object-oriented programming. So in order to understand better what is object-oriented programming, or OOP for short, let's have this comparison. First, you need to know that for the functional programming, the function is the main unit of the program. So you have many functions in your code, and you are calling this function, and then this function, and this function, and so on, right? For the object-oriented programming, we have another thing called the class. And in this case, in the object-oriented programming, the class is the main unit of the program. Of course, in a moment, we are going to learn what do we mean exactly by a class. But for now, you need to understand that the class is the main unit of the object-oriented programming. Another important distinction between functional and object-oriented programming is that the functional programming follows a top-down approach, and the object-oriented programming follows bottom-up approach. So what do we mean exactly by this? You can look at your body and say that you have arms, you have a head, you have a mouse, and so on. So these are the things that together define you, right? And you can look at your arm, and for your arm you have some fingers, right? 5 fingers in the right arm, 5 fingers in the left arm, and for the fingers you have nails, you have skin, and so on, right? So this is a top-down approach. We start from the very general, which is the function, the main function, and inside each function we have other functions that are called, and then other functions inside these inner functions that are called, and so on and so forth, right? For the object-oriented programming, it's the opposite way. We start from the cell, because the cell is the main unit of your body, and then these cells together form something that is more complex, and so on and so forth, until you reach your whole body, or you have your whole body. So this is a difference between object-oriented programming and functional programming. You can see, or you can imagine that the function is your arm, or your head, or your eyes, and so on. And for the object-oriented programming, you can see the class as your cell. So as you can see, for the functional, it's not super realistic, because in fact, the main unit of your body is the cell. So the main unit of the program should be the class. So that's why the object-oriented programming is much more realistic than the functional programming. And for the functional programming, we don't really care about the data. So far, we didn't really discuss what is the data that is stored in this function. It's just a function that takes some input and then returns some output after performing some logic on this input, right? But for the object-oriented programming, data is very important, and we are going to see this in just a moment. You will see that for each class, for each instance of the class, we have its own data. So data is very important in object-oriented programming, but for functional programming, we don't really care about the data. Another way of comparing functional and object-oriented programming is by looking at the project complexity. So if we have a big complex project, then functional programming will not really help you. It's really useful if you are going to work on a small project or intermediate project that you are developing yourself. But if you are going to work in a team, then most probably you will see that the concepts that we have in object-oriented programming can help you with complex and big projects, okay? And finally, for functional programming, we cannot really hide the data. And this can be a big problem if we have passwords, for example, or we have data that is sensitive and the user cannot really see this data, okay? On the other hand, with object-oriented programming, we can achieve data protection. So we can hide the data from the user. So this is an overview or a comparison between functional and object-oriented programming before we get started. Now, we need to understand, or we need to learn some very important object-oriented programming definitions. Let's start by the classes. When we say a class or an object-oriented programming class or a Python class, we mean the blueprint of the objects, okay? So it's a template or a backbone. For example, we can have a dog class, we didn't really specify here the color of this dog, the type of this dog, the breed of this dog, or anything, right? We just said that this is a dog, okay? So this is the backbone or a template for our code. But what we have actually inside our code, or what we use inside our code, is the object. So the object is the actual entity we interact with. So it's the instance of the class. For example, we have a 2 years black German dog. So this is a dog object right now. So we first created a class, a dog class, for all dogs, okay? And now from this class, we are creating an object. So first we need to have the template, or we need to have the blueprint, which is the class. And then from this template or from this blueprint, we can create the objects, okay? Another important definition is the attribute. So when we have attributes for the objects, it's the object characteristics. It's basically the parameters or the variables we have inside our object. So this is the object data. Also, we have a very important definition called the methods. So they are the actions or the functions that this specific object can do. For example, this specific object can fly, it can eat, it can run. So we have some functions, and now we are calling this methods, and we will see in a moment the difference between functions and methods. But for now, we will call them methods. So the methods are basically flying, eating, running, and so on. And we will see when we go to the code how we can create attributes, methods, classes, objects, and everything. Now, if we want to create our first object, we need to understand a very important keyword called the self. So when you initialize 2 or more objects of the same class, Python needs a way to differentiate between them, right? Because we can have the first object of the dog class and then a second object of the dog class. How we can differentiate between these 2 objects? They are actually coming from the same class. So we need to find a way to differentiate between these 2 classes. So the self keyword was invented for this. So the self is the way to do so. How? It's a pointer to the memory address where each object of this class is stored. So the self is basically a pointer to the memory address. So this is where this specific object is stored. You don't really have that exposure to the memory address yourself. You are calling this object by its variable name, but inside Python or inside your hardware, this is what is happening, right? You have a pointer. This self keyword is used as a pointer to the memory address where each of the objects are stored. Now, there is also a very important keyword called the class keyword. We define a class using this keyword. So it's very simple. We just use the class keyword to define a class. And it's a convention to use capital name for the class, just like this. So the first letter for the first word is capitalized, and then if we have another word for the name, we have the first letter also capitalized, and so on. And the rest are small letters. Now, before we see the first class, we need to understand also a very important idea, which is the int method or the initialization method. And this method stores the initial values for all the instance attributes. So as we said, we have instances, right? And for each instance, we have some attributes. So we need to have initial values for these attributes. So this is what the int method is doing. But in order to differentiate this method from all the other methods we have in Python, we created like this. So we have double underscores and then init, and then another double underscores, and then the circular brackets that define the functions. Also, a very important distinction for this function is that the first argument must be the self keyword we discussed. and we access the attributes of the instance using the dot operator. And we saw this dot operator when we accessed the methods or the functions for the list, for example, or the dictionary or the sets and so on. So this is an example for a class. We have a car class, and for each car we have color, we have year, we have model, for example. So how to initialize a class or how to create a class? We use the class keyword just like this, and then the name of the class, and then we have the colon, and as you can see we have a block of code here, right? We use indentation here, and the first function, as we said, or the first method is the init method. And as you can see we have double underscores and init, and then another double underscores, and of course the def keyword to specify that this is in fact a method. And as you can see, the first input for this function, or the first argument for this function, is the self keyword, right? To differentiate the different instance from each other, or the different objects from each other. And then we have the other attributes or the other parameters that we want to create the car with. So we have the color, the year, and then the model. And then we have, in order to specify or to have the initial values for each instance that we created from this class, we use the dot operator. So as you can see, self.color. So this self is referring to the current object of the car class. And then we are saying self.color equal color. So if the user specify here that the color is red, we will assign the color red to this specific instance. And the same for the year, and the same for the model. And this will be very clear when we go to the code. But before going to the code, let's understand a very important concept, which is the difference between class and instance attributes. So the attributes that are inside the init method are specific for this instance, and they are called instance attributes. But the attributes that are shared between all the instances are called class attributes, and they are defined outside the init method. To make this clear, let's look at this example. Here we have the color, the year, and the model. They are instance attributes, so they are specific to the instance. On the other hand, the number of wheels, right, the last variable here, or the last attribute here, this attribute is shared between all the objects. So this is a class attribute. So it's specific to the class because it's shared between all the instances. Finally, let's understand the difference between the functions and the methods. So the function and the method both use the keyword def in order to define the function, or in order to define a method, we use the def. And the function has inputs and outputs, and the method has inputs and outputs. But the function is created outside the class, and the method is created inside the class. So this is just naming, right? We name any function that is created outside the class as a function, and any function that is created inside the class, we just call it method. So you can use functions and methods interchangeably for now, it's fine. Okay, so let's go to the code and see how we can create our first class and understand what is the self keyword, what is the difference between class and the instance attributes, and so on. So let's go. So here we are inside Google Colab. Let's first start by the car example we discussed. So let's start by just writing the class keyword, right? After that, the name of the class is just like this. And in order to let Python know that we finished the name of the class and we want to start writing the init function and everything else, we just use this column, right? If we just enter, you will see we have indentation, right? Automatically done for us. If it's not automatically done for you, then you need to do it yourself. But for Google Colab, it will be done automatically for you. So let's now define our init method. So we will do so by just writing def and then 2 underscores, and then if we just write init and then another double underscore, and then we open the brackets for the initialization function. So if I just leave it like this, and here let's just write anything, right? So let's just write print hello. If I run this right now and try to create a car class, you will see that I have an error. Why? Because it's saying the init takes 0 positional arguments, but 1 was given. So we need to have the self keyword here. So if we just run this again, you will see that the code is running and we are printing hello. Now, if we want to have other attributes and other parameters for this specific class, you will just come here and say year, for example. Now, if we run this code again, init missing one required positional argument, which is year. So we need to come here and write car 2012, for example. Okay, so this will be the year. We don't really need to specify the self because this is done internally for you. Now, if I come here and just write car 2012, right? And then I have car 2013 and then car 2013. As you can see, this is a variable and this is another variable. So this is the car instance and this is another car instance. So this object is different from this one. So both of them are actually cars, but this car is different from this one. Why? Because we used the self keyword. So this self keyword is solving this problem for you. You don't really need to worry about this, right? But now if I just try to access the year of this car, so if I just come here and write car 2012.year, you will see that I have an error because the car object has no attribute year. Although we have a year here, we have an error here. Why? Because in order to assign the initial values, we need to come here and write self.year equal year. So if I run this again, you will see that we don't have this problem right now, and the data inside the year is 2012. Now, if I come here and try to print car 2013.year, you will see that we have 2013, right? So this is different from this one. We know this by now. Now, this is an instance attribute because the year here is different from the year here. So it's an instance attribute. Now, if we want to create a class attribute, we will just go outside the initialization function and we will just write another attribute called number of wheels, for example, right? Any car has 4 wheels. So if we just do something like this, you will see now when we run this, if I try to access car 2012 number of wheels, you will see that we have 4, although it didn't initialize it. And here we have also 4 wheels. So if you want to have attributes that are shared for all the instances, you will create these attributes outside the initialization function. But if you want attributes that are specific for this specific instance, then you need to create them inside the initialization function. So by this, we conclude the object-oriented programming part of the course, and we conclude the Python part of the course. We conclude this section. This is all the information you need in order to get started in the data science and the machine learning parts in the course. And of course, in these parts, you will find that you are practicing Python more and more and more, so you will have a ton of experience once you finish the course. So let's go to the next lesson.